My name is Pijus, on the right, all the way on the right. And I work at WIX. Those two presentations are not necessarily to be considered like a separate talks. We do them separately, but it was designed as a longer session, even more extended with more talks. So they are related, so it's alright, just both as one thing. And the idea behind this whole talking about Graal is that many people do hear about it. They don't really know what it is. I think they should know what it is, or at least why the hype is, why the hype, So my part is that I'm going to onboard everyone on why is it important, why should you care, especially as a Java developer, and why do people talk about it. So I'll start really slow. Basically, when you work day to day, you have your regular code, Java, C long, Scala for me. Then you compile it into a bytecode, you get this fat jar that you send to a server, you run it on JVM, and it gets translated into native code, and all of that executes the actual logic. And behind the scenes, you can look at it as different types of bytes, right? Like array of bytes, just different way, format, etc. And actually, the latter transformation happens in JVM, right? Bytecode gets translated into native code for execution. You look even deeper, you have the virtual machine for runtime, and you have the compiler that does parsing and translation itself. And historically, they both are written in C. Why is it important? Well, a while ago, guys at Oracle, they basically said, okay, it's enough. Actually, a while ago was like 5 years ago, like 4 and a little bit. And so the idea is that they wanted to write, do something so that you could enable a compiler written in Java to be used by the JVM. Why do they need it? They basically state should allow production of a high-quality compiler that will be easier to maintain and improve than existing compilers developed in C or C++. So basically they said, okay, we have huge legacy compiler written in C, nobody wants to work on it, nobody is capable of that, or at least people are retiring or dying. So, the story, I think every bank has this legacy, every company has some kind of legacy, and this was for Oracle, for JVM team. And so yeah, they introduced a boundary which allowed them to write compiling Java. And Graal is exactly that. Graal is the new compiler for JVM as you know it. It's just a rewrite of a compiler with new stuff, newer, better, etc. And actually, guys at Oracle Labs, they really talk about how easy it is now to develop the compiler, how easy it is to develop optimizations. You can use the same tool in debugger, etc., profiles, etc. They are very satisfied with that. But for me as a developer, it was, okay, good for you. I don't really care about compiler. It's something I expect just to work, For most stuff, I don't even care about the performance of my code. It's good enough. I'll add extra 10 servers. It will go right. Yeah, or add some RAM. Depends. So yeah, actually, the only thing I might care in some cases is if it's actually more performant and really more performant. And that's one of the reasons why Graal got some hype around it. So a while ago, it's in 2017, a guy from Twitter started talking about how they started using Graal and they saw 11% performance boost just out of the box. They messed around, they got a couple more percent. And that's actually significant, especially if you consider Twitter case, Microsoft, Oracle, all those big companies. 11% is a lot. And actually Oracle guys lately have been talking about 25% boost for Twitter, so that's huge. But the problem is that we at WIX, we have evaluated it, and the performance boost is not as one-sided. In some cases, it's actually even slower than the C2 compiler, for example. And if you Google Graal now, you would find some blog posts which say, oh, it's just slower, like it's not as good. But you know, it's a new thing. It will get a lot better, and in some cases, it's definitely faster. For example, if you use a lot of Java streams, you do a lot of reactive programming, Graal has amazing optimizations for that. It will work way, way faster, even more than 10%. So that's something to note. Also, Twitter talked about another thing, which is that Graal makes your application GC less. So that's also good. Again, it's probably good, but not that significant, I would say. And a huge question is, okay, so it's faster. I don't have to do anything, right? You know, I don't have to write special Java for this. Yes. Can I use it? When will I be able to use it? So the answer is that you can already. It's actually being shipped with JDK 9 and up already. It's not enabled by default for JIT. It's only enabled for ahead of time compilations, as far as I know. And you have to use those flags just to enable it. It's that easy, not very complicated, right? Or you can also go to GraalVM.org and download the pre-configured bundle. So yeah, you have, again, it's Oracle, so you have Community Edition and Enterprise Edition, you know the story. And some of you may have already noticed that there are two terms, basically. I've been talking about Graal lately. And there's another thing, GraalVM, which is not the same thing, and people confuse it a lot. So Graal is the compiler. As I said, it's a rewrite of existing compiler. And GraalVM is JVM with Graal, with truffle, which I'm going to talk about later. And a couple of language implementations, again, later. But basically, GraalVM is pre-configured JVM. You just download installers, usually put it somewhere in the path, and use it. You know, Java, Java C, etc. all comes with that. So it's the whole development JDK with runtime. Very easy to use. And yeah, Graal is the new compiler. Woohoo! But now, I want to talk about something more interesting than just a new compiler that just happens to be there. Okay? So I'm going to move things around. So I'm going to put this native American flag for the native code and this chocolate cake for the bytecode. I don't really care about it, but the magic happens here. Like in between that, what you have is basically an abstract syntax tree, or AST. It's an in-memory data structure. It represents your application logic at very low level, like take those two arguments, add them, you get the result. You invoke a function with these parameters, that kind of thing. Very basic, very low, etc. It's not interesting in the sense that pretty much all modern compilers have this in one way or another, at least most, because it's very convenient for compilers to use it for optimization, but that's not particularly important. The fun thing about this is that Graal actually exposes it as an API, which means you can parse whatever you want, as long as you construct those abstract syntax trees. You can just shove it into Graal and it will compile it, run it, optimize, and etc. So, and since those are very low level, you can actually implement pretty much any language with that. You can implement any parser compiler for this. So Graal, which is the more important part, is a language agnostic compiler. Which means, again, it doesn't care what the input comes from, what kind of language it works with. It only cares about the tree, which is always, the same format. And actually, the guys at Oracle Labs, they even developed this truffle framework, which I already mentioned. It's just meant to be a set of common node types. Again, pretty much all languages have some kind of function invocations, constructions of objects, adding things, moving around loops, that kind of thing. So there's no point to implementing it for every language. So they provide it out of the box. They also give you some optimizations as a language developer. And actually, there's one cool thing they give. I guess not many people know, but Traditionally, when you get taught how does application work, how do function calls work, you would be told like you take parameters, you put them into stack, you invoke it, you do stuff, you put result back into the stack, you go back, you take it out, etc. But actually it's a very slow approach. Modern languages like Java actually don't do that for many cases. You can actually mess around with registries and do it a lot faster. So as a matter of fact, Truffle comes with this optimization, which is somewhat difficult for language developers to overcome. And for some languages, just because it was implemented on Truffle, it meant huge performance implications and huge performance boost just because of those well-developed optimizations. So yeah, it's good for language developers. And looking at the whole architecture, stack of GraalVM, you still have the virtual machine at the bottom, which is written in C. You have the interface, which I mentioned. You have the compiler, which out of the box supports any kind of bytecode input. And if you want to do anything else, you can actually use Truffle to supply it with abstract syntax trees. And actually, guys at Oracle Labs, they have already implemented Ruby, R, and JavaScript support. For example, for Ruby and R, the performance boost is quite good. Yeah, and also, interesting thing is that they also implemented Sulum support, which basically means, well, it's not as straightforward, you have to take an extra step, but you can execute native applications on Java virtual machine. And that, it's interesting because, well, we've never been running those native applications on a virtual machine, right? At least not at this level. Yeah. Even though, like I've been researching about this a while ago because I found it somewhat interesting, people talking about it. And, yet another polyglot implementation, right? We've seen those. They all used to suck. Their syntax was too hard to use. Performance was too bad, to make it usable. Or maybe it's debuggability that, you run into an issue and you basically throw out the code because you can't figure out why it doesn't work. It was just too painful to have application written in multiple languages. And it's one of the things GraalVM kind of aims to solve. I'm not going into detail because this is the part where Milda comes in, so you have to wait for this. But what I want to talk about is something I find cool, something what for you can use Graal. What are the implications for us? So one fun thing is that the Oracle guys, they run around, they do demos, and in this particular case you can see that he's sitting in Chrome. He's actually debugging Ruby application. You can see the .rb extensions, and he's doing that line by line with all the fun toys Chrome comes from. I don't know why you would do that. I don't know why they even thought of implementing this, but they did implement a special flag where they expose Chrome debugger interface so you can debug your even Java application with Chrome. I usually use Chrome for like YouTube and Gmail for my work, so I don't know. Maybe sometime in the future we'll use it, but it's just for me it's a fun toy, but it's something we can do now. Yeah. Another example they show, which is more interesting, which is he goes on and talks about things like, okay, there's this NPM module, it validates stuff, and yeah, he goes on and just starts SQL Server, and if you can't see, he's actually running that NPM module inside SQL Server. Like he writes SQL, runs it, and he gets the result. Again, like it kind of makes me cringe as an engineer. Why would you do that? But at the same time, it kind of makes me smile and warm at heart because, of course, you do that because you can. Like you stuff, you I don't know, duct tape everything together and it works. It's amazing. I guess the main idea is that you can now do optimization, I would say. For example, take your database, take your business logic and glue them together into one process, one deployable. So basically avoid the whole network stack. You can just do the things directly, right? Which is in some sense is okay, but I know how frequently stuff breaks, so I don't know. The practicality is questionable, but have in mind you can do that. Yes. And of course, let's talk about something more complicated. We are towards the end of my part. I just want to mention a couple more things that you can use Graal for, or potential usages, potential implications. So one obvious use case is supporting legacy projects. Like I believe if you've worked in this industry for at least 10 years or something, maybe even less, you've seen some crappy code. You've seen some application which was written in whatever language and you don't want to deal with it. So with Graal you can actually just run it and add additions to it, or you can start rewriting just piece by piece, not even not taking the whole process and doing big bang. You just piece by piece. It's very nice. So I think this is a legitimate use case actually, and I think it's very beneficial. Another thing is that I haven't seen many of those cases, but I have seen cases where people would choose particular language just because there is that one library that does the job very well, and not necessarily because they know the language, they like the language, etc. So in this case, you can take one library that works if you really need it, and plug it into GraalVM and continue developing, I guess in your case, in Java. So that's another use case which is absolutely possible. And there's another one related to truffle I mentioned. I'm actually one of those developers who really like languages, and I'm interested in many different languages. I do believe that you should learn more than one language. But what I want to talk about is basically, till today, it's been quite difficult and challenging to develop a new language or to propose new features in languages. But with Graal, you basically it comes with fun things that you can just take and use it. You just have to implement parser, and you get all the optimizations, you get all the common structures that you need in your language. It makes things easier. Also, you can take, for example, JavaScript implementation they have from Oracle, fork it, and do some fun JavaScript syntax additions, for example. And I do like this idea because with open source projects, that's how they propose features very frequently. Why not do that with languages? I think that might be somewhat cool. Another thing is that Graal allows you to plug new optimizations, custom ones. So again, maybe you have very specific use case. Maybe you can think of a good way to make your application run faster. So maybe that's good for companies. Again, going back to open source, maybe we can see some open source optimizations for specific use cases, or something like that. Just take this jar, plug it into your JVM, and your application will run SQL 10% faster, whatever, that kind of thing. And another thing which comes from Oracle, I guess, lately they've been talking about how Docker sucks. And they actually propose things like taking GraalVM and using it as a base for multiple applications per server. Because GraalVM actually comes with memory isolation, I/O isolation, sandboxing, and a couple more things that are useful for cloud computing and separating applications. So yeah, you can basically take multiple applications, run on single JVM, and their idea is that you can optimize resources that way. You can also implement something like cloud functions on GraalVM because of this kind of thin isolation layer, which is also somewhat performant. So, I don't know. Maybe we can see something come out of that too. For those who has worked with Google App Engine, you probably know how long it takes for Google to develop new language support. For example, Java 8 took ages to, be available on Google App Engine. It wouldn't, like solve the 100% issues with GraalVM, but it would help, I guess. So maybe we can see something there. Oracle suggests that we will, in the future, see something useful there. Okay, last thing is that many things, again, many people have heard about GraalVM, never used it. So I just want to show you how easy it is to, get it on your machine and just start using it. So you just go to the repo or the website, doesn't really matter. You go to releases, you take one of the tars, download it, extract it, and you have a bunch of binaries. Easy as that. For Node, you can see like we have Node, npm. What you would do, the same is for Java as well, you would put it into the path, and you get those extra flags on top of regular Java or Node or whatever, which allows you to run polyglot applications. And it's easy as that, like really, just download, modify the environment variable, and it works. So I think that's amazing. So yeah, my part is over. Thank you. I guess for the questions we can wait for till the end, right? So yeah.
So hi, can you hear me? Can you?
It's really good now.
Now you can hear me. So I'll move in. Okay, so I'll continue talking about GraalVM, focusing more on its polyglot feature. And I like to start by introducing myself. My name is Milda. I'm also a software developer at WIX, and this is a picture of my dog because my dog is very cute and I like to put the pictures of her wherever I can. So she's very cute, right? Okay. So let's jump into GraalVM. So one of their main selling points when introducing it was giving us the ability to write a truly polyglot applications, and this is the introduction that I stole from their official website. And what they promise is that these applications will be seamless, they will be high performance, and they will come with no additional cost on crossing the language boundaries. And in this presentation I would like to actually check if it's the case. But let's start with why do we need that? And have you ever wondered how many programming languages there are in the world? Like depending on your sources and on your criteria, like is this a programming language? Because it's the actual Hello World implementation in the language called emoji code. So you decide if it's the actual language or it's a joke, but it works. And then I consulted the source of all truths, Wikipedia, and they have listed over 700 programming languages, which is a lot, like the actual languages. And why do we have that many? Why do we need them? And it is like that because we have a different criteria on what makes a programming language good. And some languages are good in one thing, and some languages are good for other tasks, and sometimes we want to mix and match these languages for our different tasks. So it makes sense that we want to use different languages. And what would we do right now without GraalVM? So let's say, for example, I have a Java application, and I would like to do some R for my statistics, and I have Java on one virtual machine and R on the other. So to call R code, I will have to go outside the virtual machine into the another one through some kind of API and then go back, which is obviously a very costly situation. On the other hand, we have things as JRuby, which is a Ruby implementation on top of JVM, which allows the interoperability between Ruby and Java, and it's on the same virtual machine, so it's better. You don't have to leave the virtual machine, but well, it's still not perfect. As firstly, it's not polyglot; it's bilingual. It's only 2 languages. And also, maybe if you know how the JRuby works, so the Ruby and Java code is compiled into the Java bytecode, and then the Java bytecode is thrown blindly into the JVM, and not even the JRuby developers themselves know exactly what's happening with this Java bytecode inside the JVM. And what the GraalVM developers did, they removed this Java bytecode step. Instead, they expressed all of the languages in the compatible way and exposed the wide API into the virtual machine, allowing the language developers to pass custom optimizations and know exactly what's happening with this code. And also, they can mix and match different languages because they are very compatible. And I will go into detail why and how, and before that I will just quickly mention Mathstorm, which is the Oracle itself's JavaScript implementation on top of the JVM, and actually it was suddenly discontinued and everybody was like, why? People are using it, and actually now with the GraalVM it makes much more sense because on GraalVM it's much more efficient and much faster. So I will now talk about how it works, and I won't go into too much technical detail. For that I put a link into one of the Oracle developers' research paper, and they explain it very well there in more technical detail. It's a scientific paper, so I recommend to read it if you're interested in technicalities. But for the shorter version, they made the polyglot work by introducing a polyglot interoperability protocol, which means that each of the languages implemented on the GraalVM have their language-specific operations mapped to this predefined set of language-independent messages. As here, for example, as JavaScript implemented on GraalVM has their object access operation, the dot, mapped to the language-independent read message, and the C language also has their object access method mapped to the same message. So if we're in a JavaScript program, we can reach the C language-specific operation through this message. And to better understand that, you have to remember that each of the program on GraalVM is represented as a tree data structure. And here I have a little piece of JavaScript code, A equals object.value, and the language interpreter would translate my source code into this kind of tree. But what would happen if this object is, for example, a C object? So the language interpreter would map this dot, the language-specific operation, to a language-independent message, and then at runtime, this language-independent message could be replaced to the guest language, the C language-specific operation. And the compiler actually doesn't even care where these three nodes come from. For the compiler, this is just another tree, and it doesn't matter if it's C, if it's Java, if it's JavaScript. And you can pay attention to this C node, so if at runtime you would dynamically change your C object to, let's say, a Ruby object or a Java object, it could go back to this language-independent state and then change it to the Ruby language-specific operation, because it's also mapped to the same message. So, as you can see, there actually isn't that much performance cost in crossing the language barrier. So the actual performance comes from the languages itself implementation on top of the GraalVM. And if you looked a few years ago, they were stating that the goal is that each language would have a similar level of performance that the Java has. But if you go to their official sites right now, they call their performance competitive, which is a word to describe performance. And let's try, let's see how it actually looks. I will do some live coding because it's very dangerous to do it. Okay, I chose my languages to be Java and JavaScript because these are the languages that I work with. Actually, it's a lie, I work with Scala, but it's close enough. And I chose Java as my main language, so I will be calling JavaScript from my Java application. So let's start. For that, I will have to create a polyglot context. Can you see actually well?
Yes.
It will be a context for JavaScript. And this is it actually. Now that I have this context, I can put the language ID that I'm using, and I can start writing my JavaScript code. Okay, I'll save it. I'll go not here, not here, here. Firstly, you can see that I'm using the GraalVM, not the regular Java, and I will just compile and run it, and it works. It's JavaScript operation. And if we would like to do some more fancy stuff, what would happen? What would I have to do if I would like to pass, let's say, a message that I defined in Java? I wish it worked just like that, but it actually doesn't. For that, I will have to create a bindings object. So bindings object is basically a bridge between the languages. Each of the languages on the JVM has, like in this context, has their binding objects, and through this bridge I can pass the symbols between these two languages, so that another language can recognize the name from the other language. So I will... So the main message in this JavaScript will be the message from Java. I save it. Where's my... It's not right. Okay, I run it. And it also works. And the same way I could get the values from JavaScript into Java. And I will try to do it, but actually with a function. I would like to use a function in my Java code that I have defined in JavaScript. This is the function. It takes two numbers and it adds them. And I can do that by... Well, firstly, I will evaluate this JavaScript code. And I will take this function through the bindings object. And actually I can now use it. And I have to explicitly state that this is an executable that I want to execute it. And I will put two numbers. I save it. Okay, this will work. Okay. So by default, the context doesn't allow the I/O operations, so you have to state that I want to do that, because I'm using another file for the JavaScript code. And now it works. And one last quick step. What I want to do, I have a Java class. It's called dog. It has a name. It can bark, and I would like to do something with this class inside the JavaScript, like in JavaScript code, and I can also do that. I will just do an object. So yeah, that was my show and tell for the GraalVM. It actually is possible to do something with it. And I will start with the downsides. As you could have seen, it's not that seamless. I have to create the context, I have to pass the names through this bindings object. It actually looks quite ugly in this simple use. Also, you can imagine that if it's ugly to work with the legacy code right now, just imagine working with this polyglot legacy code. It would really suck. So even the Oracle developers themselves don't recommend just to go ahead and mix and match languages. It's fun. It's actually not. The maintenance of it would be really ugly. And for me it was quite sad because I'm working with NodeJs quite a lot now. And from Java I can run NodeJs on GraalVM, but from Java I cannot call NodeJs, I can call only pure JavaScript, and it was a decision made to do that. And, but there are, of course, some wild use cases, as Pijus mentioned some. There are some very specific tasks where maybe it's work to have this ugly seam in your code, but like if you write a Java application, but you want to do some machine learning and put maybe some Python in your Java application, maybe it's worth it. You can judge yourself. Also, if you're migrating from one language to another, it's good for this intermediate state. And if you have some library which your front-end uses and you want to use it also with the back-end, it might be quite convenient if you run on GraalVM. So is it new? Is it exciting and fun? Yes. Will I use it in my next project? I will think about it. Thank you. So any questions from any of the talks?
How do you test it?
How do I test it?
Yeah.
Well, it runs on JVM, so anything that you would use to test your Java application, it works also. The exceptions in this, if you get like a JavaScript exception inside your Java application, it will be wrapped in this polyglot exception, and you can actually see the stack trace quite well, and you can test it as a normal Java application.
So that means every language which you want to run on GraalVM needs to be explicitly implemented for GraalVM.
Yes.
So it makes languages not like dependent on GraalVM, and we kind of lose all the benefits they get from their platform, such as NodeJs and JavaScript. So it kind of makes it useful only when you want to use custom syntaxes, right?
No, not exactly. For example, specifically for JavaScript, yes, V8 is very performant and it's basically very well optimized for JavaScript and that kind of thing. But even on Graal, it's somewhat decent performance. It's not as good at the moment. They promise it will be better, but yeah. I guess for the major languages, performance benefit wouldn't be as clear because they do get a lot of money, a lot of time invested. But for languages, again, languages like R or Ruby, performance benefit is a lot greater because those haven't been developed as much as, for example, JVM. And Oracle does invest a lot in JVM. So yeah, but you are right about the fact that it basically needs to be a specific implementation for JVM.
By specific implementation, it means specific implementation of specific language, right? So it has no kind of bridge to native language execution engine.
Pretty much. For example, you can look at how they did it with native applications. In that sense, you don't have to implement, for example, separate language support, for example, for Rust, C, Go. You can just take already, languages which are being compiled to native code, run it through LLVM compiler, and you get this kind of, intermediate state, kind of like bytecode for Java. And that one, so long you support it on GraalVM.
When it comes to bytecode, so does it mean that if I, for instance, use JavaScript, I will benefit from garbage collection, which is present in JVM in case of because in JavaScript, as far as I know, there is no such thing. So does it mean that will fly
Wait. Do you mean like there is no such thing as garbage collection?
No, there is no such thing as far as I know. I'm not a guru of JavaScript, but in vanilla JavaScript, as far as I know, there is no such thing.
As garbage collection?
As garbage collection.
No.
Well, definitely JavaScript is a language with garbage collection. It's a managed memory language. But for example, let's take C. It's not a managed language and it doesn't have garbage collector. Okay, for JavaScript it will make use of JVM garbage collector. It's the part of virtual machine to take care of memory things. For example, in C it's not managed, and actually garbage collector in JVM is not going to deal with that. It's kind of like you pick an unsafe language, so you are not saved by JVM. So yeah, it's your choice. You know, if you pick a language that would normally use garbage collector, you will definitely make use of JVM garbage collector. So it depends on the language you are picking. Yes.
Algorithms used will be JVM.
So
algorithms which will be used in garbage collection will be algorithms of JVM.
Yes. Those are not garbage collection is not implemented for every language. So it's part of virtual machine actually, it's part of managing runtime, so it will always be one of the JVM garbage collectors. And again, you can configure it, you know, with flags. So yeah.
What kind of limitations and issues will I encounter if I want to migrate my Java application from JVM to GraalVM?
Pretty much none, because okay, I didn't say the line, but regardless if you like GraalVM, well, not GraalVM, Graal or not, it's the new compiler for JVM. Even the guys developing Graal, they are, you know, being asked around like when is it going to be released as the default, and they basically say that it's pretty much ready to be stable. They are just waiting for the JVM team, you know, to say they are stable first. But it will become the default, so there's no transition for Java developers. It will be seamless, well, hopefully. You definitely don't have to do anything. It's just that, you know, it's a rewrite, so maybe some bugs come up, so other than that, there's nothing to worry about, yes.
What's the difference between two licenses? Because two licenses for the GraalVM community and enterprise. And what license do you use in production?
Yes, those are not exactly licenses. Those are two separate editions. Graal itself is open source, and it's called the community edition. Everything open source is built into a community edition, and it's free to use, you know, as it is.
But who owns this community edition? Still Oracle, or it's some special?
No, it's Oracle. It's under Oracle, but their license is, you know, free for anything, basically. In terms of Enterprise Edition, it's more interesting. They actually, it's definitely not free. It does come with support and that kind of stuff, and extra optimizations, which basically mean that Enterprise Edition is more performant in terms of runtime. Yes, obviously.
What do you use in production?
Huh?
What type of the product do you use in production? Community or?
I think we don't use Enterprise Edition, and yeah, we don't use it widely at WIX. We did for something, but you know, it was relatively small. Okay, Enterprise Edition pricing is somewhat interesting. Basically, they don't state the price, so basically it says like email our marketing sales. So basically, the richer you are, the more expensive it will be. So yeah.
Can you drop it lower?
Yeah. Yeah.
Can I ask a question?
Do you have some real-life business examples of polyglot thing? I mean, when you had to actually to do this.
So there was a team who did a migration, which basically reused the library, like the logic that was in their front-end library. So they used GraalVM for this migration, just temporarily. But with GraalVM, they could reuse the same library and didn't have to rewrite it in their backend where they were doing the migration.
One interesting thing to note, and it's related to this use case. Milda mentioned things like you don't get Node.js, you know, you get JavaScript. So basically what that means, you can't require, you can't use, you know, just require NodeJs, for example. Same goes for front-end, same goes for backend code. But you can work around it with things like Webpack. For those who don't know, Webpack will just go and pretty much bundle everything into a single JavaScript file, which is pure JavaScript if you configure it properly. So that way you can get the benefit of Node.js modules and run it on GraalVM. Just you have to take the extra step. Yes.
Could you repeat maybe? I didn't get it right. But what is that bytecode? New bytecode? What looks like?
No, bytecode hasn't changed. It's okay. When you do like Java C or compile Java, for example, you get jar. Inside jar, you have class files, which are basically bytecode formatted binary file. So this is the intermediate state for your application logic, which is platform independent. You just move it around and you run it on JVM. So bytecode is the intermediate between your Java code and runtime native. Just that, nothing more. And it hasn't changed.
What about JIT optimizations? They won't be available as GraalVM uses ahead of time compilation.
That's not exactly true. Graal is a compiler. It can be used for ahead of time compilation. It can be for just-in-time compilation. So, yes.
But GraalVM uses ahead of time.
No. Depends on how you use it. You can, again, GraalVM is the same JVM, just configured to use Graal by default. So if you use it for ahead of time compilation, it will be that. And it loses things like reflection unless you specify specific things explicitly. But for just running application on JVM, as usually, it will be just-in-time compilation and you will have everything the same. So there's nothing to worry. Again, Graal is a replacement for the old C2 compiler, so it needs to be feature-rich in a sense that it needs to be equivalent more or less.
Okay, let's finish at the moment. Let's make a break. It's not alcohol, it's just all the grape juice. Thank you, both of you. One is for you, and for you, and as you know, Latvian chocolate is the best in the world.
Of course.
Yeah. So thank you for